Hey students, a very warm welcome to all of you. Your Anubha ma'am is here in front of you and your most awaited chapter in English channel also is back. That's Coven and its compound. So I hope you are excited enough to have this video, and yeah ma'am, we'll do it very good and we are very excited, and this chapter is going to be very easy. Trust me, all of the myths that this chapter is a bit typical is going to be completely broken. Okay, so just stay with me till the end in each and every session and your problems are like shoo. Okay everyone, yes, CBSE 10 students, so I have something to tell you that how this platform called as Vedantu can help you to solve all your problems, academic problem I meant, problems like if your doubts are not getting solved, instantly whenever you feel, yeah, I got stuck at that moment of time, your doubts can get solved easily at that moment of time with an expert of team your master teachers are going to have called as class teachers, totally dedicated to solve your doubts. Notes like ma'am, our 60 to 70% time is going away in making notes. That will not happen because every session's notes you will get easily, and in every 15 days there will be a test so that you won't forget whatever you have taught. Repeatedly tests to make you completely learning accessible and to see your growth. Assignment after every session, a small one, so that you will make sure that you learn that topic properly. Competitive exams preparation with some special foundation courses side by side with your boards classes. Here you can prepare for JEE, NEET, Olympiad and NTSC. Everything is possible, and that too with the choice of your own schedule. It's like your master how you will plan your studies, and you just see at every time you can see the session here with the choice of language, like I'm talking about Hindi, English or English. You can totally choose. We have language specific batches as well. I meant Hindi and English. So all problems will solve also. Also, you will get bonuses, including that means live classes like unlimited 8 to 10 also you can attend. Micro courses, chapter based courses, as many as you want, so that every chapter will be very easy for you. You can revise even 100 times. Crash courses, performance report in every session, and also personalized teachers of your personalized attention of your teachers as well as class teachers to solve your doubts. So what you all have to do, some small thing that you need to do, that is go to the link given by Vedantu 19 channel in the description box, that is pinned by Vedantu 19 channel, and you just have to click on it and have to apply a very magical code, that's AGEPRO. Why that's magical? Because that's your AG ma'am's code, AG Anubha Kaur ma'am. E is this channel, English channel, and Pro is this course. So AGE Pro, hence this is the code. And that way you can save from 20 to 43% on MRP according to the time duration you will choose, like 1 month, 3 months and 6 months. Three kind of a courses you can have, and totally awesome. Every course is awesome. It's just what you will choose, what you'll think that is beneficial for you. And see how and why I'm telling you this, that Vedantu has proven it again with the JEE advanced result, toughest exam of India, I must say, that how great the students of our platform performed. Just see the amazing numbers. Top if I talk about top 500, 5 students got selected in top 500, 11 in top 1000, 44 in top 2000, 121 in top 5000, and 253 in top 10,000. That's the result of JEE Advanced. And these awesome faces, you can also be there at the same place. Just have some trust yourself, trust this platform. Everything is possible, students. Everything is possible. So yeah, just do that. Take this as an opportunity. And one more thing, if you also want to be a part of KBC 2020 season, here is a golden chance. What you all have to do, just download the Vedantu app now and play week quiz as much as possible. and your dreams can totally be true. You can be with Mr. Bachchan on the same hot seat and can fulfill your dreams. I wish I could do the same. So play week with students, play week with, and that's totally possible. All right, all right. Okay. So in this session, we'll talk about why this carbon is so special that there's an entire chapter of carbon we need to study, and what exactly is the kind of bonding it's going to have. That's the reason that it is so versatile that millions of compounds are possible because of this carbon. So are you all ready? What about hitting the like button and subscribing to the channel and sharing it to your friends, because carbon teaches us that sharing is caring. All right, everyone. So let's start right away, right away, right away. Okay, I'll ask this question to you only, that have you seen carbon in day-to-day life? Don't say no, because carbon is everywhere. If I talk about this ma'am sitting in front of you, you guys, this screen and everything, even the phone that you're going to have or having, is definitely having so much amount of carbon. The clothes that you wear, the hair that you have, and the books that you read, everything is having carbon. I must say that without carbon, Earth is not going to have any life. We all are carbon based students. All the plants, animals, we all are carbon based. That's how we look like this. Maybe we are not able to see some other life, alien life in other planets, because maybe we are having this notion in our mind that maybe carbon is life is carbon based. That could be some other element, some other atom based as well, right? So yeah, that's like breakthrough that can happen any moment of time in future. So let's see where else. If I talk about the ink that you use is also having carbon, one form, that's graphite, giving that black color. And students, apart from that, the shoe polish also in front of you, carbon black, one of the form of carbon. Carbon footprints, that's one of the question that I also want to ask you, that have you heard about carbon footprint, and do let me know what exactly is that detailed information. Yeah, have you seen carbon in your day-to-day life? It means coal, that everyone is like, yeah, let's have some barbecue and all, and they put it on coal fire. Again, coal, carbon. The food that you eat, everyone, carbohydrate, that means sugar. If I talk about proteins, vitamins, all of these kind of a fat also, all of these kind of a things are nothing but having carbon long chain. So carbon is very much possible, and if I'll tell you this number, you will get shocked that carbon is just 0.02% in our earth crust, and in atmosphere, if I talk about CO2, that's 0.03%. Still, the amount of compound that carbon makes is like not even close to the other elements making all the compounds. Strange but true, students. Strange but true. And you know that in earth crust, carbon is there in the form of minerals. It's like carbonate, bicarbonate. CO3 is your carbonate, HCO3 is bicarbonate. So carbon is there. Other kind of minerals contain carbon. Coal and petroleum, again having carbon. So carbon is definitely there. Atmosphere is also having carbon. So the thing is, why carbon is so special? Let's talk about that as well. So very first reason is its valency. And I hope you remember valency, the combining capacity of an element. Combining capacity means how my carbon is going to combine with the other elements. And why carbon needs the same? Because carbon needs to needs to complete its octet, right? To complete its octet, it is going to share 4 electron with other atom, and that will define its valency. Why sharing? We'll talk about the same as well. So I hope this part is pretty much clear that carbon came from a word. Carbon came from a word carbo, and carbo means coal. So that's also pretty much important, that first of all, coal is the very much first significance, very much first reference that we took. Carbon's atomic number is 6. Yeah, configuration 2,4. 4 is the valence electron, and that defining its valency also. That 4 electron it's having to complete its octet to follow almost noble gas configuration. It is going to need 4 more electron, or will donate 4 electron, or will share 4 electron. But let's see what it will do. So you know that for making ionic bond, what your substance has to do, your element has to do, one has to lose electron, another has to accept it. The best example is like NaCl. You can see that, a very good GIF. Sodium is having a configuration 2H1 and chlorine is 2H7. Basically, ionic compound is formed between a metal and non-metal. A metal and non-metal. Metal is going to lose electron and non-metal is going to accept those electron. Metal is like, if I lose this electron, I'll be stable because my octet will be completed. My non-metal is like, if I gain electron, I'll be stable because my octet will be completed. So sodium is going to give an electron, or you say chlorine will take it, lose 1 electron, 1 positive, because an electron is lost. So 1 proton is extra on the same atom now. It's not like we have added. Sodium had 11 proton, 11 electron, 1 electron lost, 11 proton, 10 electron. See the total charge? 1 positive, right? Same. Chlorine accepted that electron, so 1 negative. So ionic bond is formed by losing and gaining. And we can also say transferring of electron completely. And there must have some charge. But when I talk about carbon, how carbon is going to combine with the other atoms, specifically non-metal? Non-metal combines, and what kind of a bond they'll form? Non-metal, electron deficient. Non-metal, electron deficient. So they both are like, we are family. Let's have this common, sharing and caring nature, that we can't both take electron from something. So let's share each other's electron and combine by overlapping each other's electron. Yeah. So let's talk that why carbon is not losing 4 and gaining 4 one by one. If it were to gain or lose electron, let's see. It could gain 4 electron, and what it will give? C4 negative ion, right? No denial that, yes, my carbon is having configuration 2, 4. 4 electron if is given to it, carbon will become 4 negative. Now the thing is, it would be difficult for the nucleus with 6 proton to hold 10 electron. Your nucleus is like a poor one now, because proton are just 6 in number, 6 positive charge on the nucleus, and electrons became 10. 10 electron. Your nucleus is telling, I don't have ability to hold 10 electron because I became poor now. No that much force of attraction my nucleus will be able to apply on these electron. One of the reason. Also, when carbon started accepting electron, 2, 4, 1 electron is getting accepted, it became 2, 5. That means carbon acquired negative charge. Other electron is approaching for the same, and when electron is approaching, this carbon now itself is telling that I became negative. Now 1 more electron if you are giving to me, to put that electron as negative, and electron is negative, repulsion is there, to put that electron now to me, you will be needing very high amount of energy to do so. So when you will add electron, started adding electron, energy requirement to gain electron will be very, very high. So gaining of electron, what will happen? Excess amount of energy is required, because carbon started becoming negative. As negatively charged electron is approaching, negative repulsion, and excess amount of energy is required, called as electron gain enthalpy. To gain electron, whatever is the amount of energy here, that's needed to do the same. So very much difficult. 4 electron. It's not like a joke. On the same hand, losing 4 electron is also almost, not a good idea, because in 11th also you'll talk about this concept. When you lose electron from a substance, you need energy called as ionization energy. Okay, ionization energy. So when electron is lost, you'll be needing energy. And with the loss of electron, carbon is becoming positive and positive. So what will happen when the magnitude of positive charge increase? When your substance is becoming more and more positive, that means more positive means your nucleus is becoming more and more strong because positive charge is getting increased. Your nucleus becoming more and more strong is holding the electron more tightly now. That means to lose these electron now is becoming very much difficult. That means to lose such electron, we'll be needing very high amount of energy, and this much high amount of energy is not favorable to have such condition. So do remember, it would require a very large amount of energy. One more thing, as magnitude of positive charge increase, as positive charge is increasing on the atom, my size of the atom, my size of that ion is getting lesser and lesser. Size is getting decreased. Okay, more and more positive charge, electron, more and more you're losing, your nucleus is becoming very much strong, holding these electron more and more tightly. Now to remove such electron now, you will be needing very high amount of energy. Conclusion is, losing 4 electron and gaining 4 electron is energetically almost not a good thing, not favorable. So how carbon is overcoming this problem? By sharing its valence electron with other atom, and the kind of sharing I'm talking about is mutual sharing. Mutual sharing means, suppose you are having 100 rupees, your friend is having 100 rupees, same amount, and you both are like, let's get some food and we both will eat it. So both are eating equally, both are sharing equally. Mutual sharing is, if my carbon is sharing 1 electron with the other atom, the other will also share 1 electron of carbon. This is mutual, equal amount of sharing. And we'll discuss so many examples with the help of electron dot structure. So let's do that how sharing is possible. And to understand the same, let's understand how this kind of a bonding called as sharing of electron covalent bonding happens, so that we can understand the example of carbon compound also. So let's do that. Okay, let's see some compounds. Let's start from hydrogen from the first place. Hydrogen's configuration is having 1 electron in its first shell, and you know it pretty well that for the first shell, duplet rule should be followed. First shell is having 2 electron rule according to Bohr and Bury rule. That first shell 2n square rule is possible. First shell is stable when you have 2 electron. So what hydrogen will do, let me tell you how to draw electron dot structure. Write electron of hydrogen with its symbol in form of either dot or cross or a star, whatever you find is convenient. You can use both time dot, both time cross, both time star, it's all up to you. Yeah. So as I told you, what is mutual sharing? Carbon will say to this hydrogen, please share your 1 electron with me because I will get stability, because my duplet will be completed. Same, this hydrogen will say to this hydrogen that I will also share your 1, I'll also follow my duplet and I'll also be stable. So they are overlapping their orbit in such a way that their duplet is getting complete. And when total 2 electrons are being shared between 2 atoms, 2 electrons being shared is called as a single covalent bond. What is covalent? Co itself means sharing. So this is a single covalent bond that we got by sharing of 2 electrons. Pretty much simple. I hope you understood it, how that happens. And to draw the diagram neat and clean, you should know how many electrons you should write on the left and right hand side of the atom to show good overlapping and a neat diagram. Okay, so let's see how hydrogen is combining. I hope you got it. I told you that's a beautiful GIF in front of you. And I hope you know that supporting this channel is equally important because we made it just for you guys. So keep supporting by hitting the like button, sharing it to your friends, and definitely subscribing to the channel if you're new. Yeah, we really appreciate it. So yeah, and let's talk about chlorine now. Chlorine's configuration again is in front of you, 287. You know what? So many students used to ask me before, ma'am, why hydrogen we write as H2? I hope that's clear, because that's a stable molecule getting stability by, the member of its own family, hydrogen. And chlorine does the same job, students. Chlorine does the same job. Chlorine having 7 electron, 1, 2, 3, 4, 5, 6, 7. Chlorine having 7 electron will do what? See, ma'am, very nicely write only one electron on this side so that my diagram will look clean, because from where bonding will occur, students, from that left and right hand side of the atom also, in between them. So I'll write that many electron that is involving in bonding. How? Chlorine 7 of its own, chlorine will say to this chlorine, share your 1 electron with me, I'll be 8 and my octet will be complete. Same this chlorine, share your 1 electron with me, my octet will also be completed, and we both are like king now, we both are stable also. So sharing 2 electrons is giving a single bond between them. And you can also share their electron, you can also show their electron, these electron, in form of dots, which is not involving in any kind of a bonding. These are not involved in any kind of a bonding. This is also right and this is also right. Okay, got it? Yes. Let's talk about one more example, one more type of covalent bonding, how oxygen is going to combine with other oxygen. Oxygen's configuration 2, 6. Write 6 electron, 1, 2, 3, 4, 5, 6. Why 2 on this side? Because 6 has to share 2 electron. 6 has to share 2 electron to complete its octet. Why ma'am is writing in pair? Because generally electron exists in form of pair. 1, 2, 3, 4, 5, 6. Alright, again 6 sharing of 2 electron. 6 sharing of 2 electrons. Sharing is caring, but the best part is when these two orbits of oxygen is getting overlapped, there are total 4 electrons being shared, and 4 electrons, also called as 2 electron pair, being shared between 2 atoms is rising a double covalent bond. So we read about single covalent bond. This is a case of double covalent bond. Let's talk about nitrogen now. Having configuration 2, 5. 5 needs to share 3, means it will make a triple covalent bond. Let's see how. In front of you, nitrogen 5 valence electron, nitrogen 5 valence electron. See why I wrote 3, 3? Because I know that there will be a sharing of 3 electron, because 5 has to share 3. So 5 will share 3 on this side, 5 will share 3 on this side. Sharing is caring, that's what. And sharing of 6 electron, that means 3 pair of electron between 2 atoms is rising a triple covalent bond. A triple covalent bond. So in conclusion, I can write nitrogen making a triple bond with other nitrogen, and these two electron are not using, so we can write it as such. Even if you don't write, it's okay, but that's a better way to write it. Pretty much awesome. So these are the 3 different kind of a bonding, covalent bonding, that's possible between different non-metals. That's single, double and triple bond. Alright students, awesome. Now let's talk about some more variation of chemical bonding. Let's discuss the structure of ammonia as well. Can you draw that? Yeah, I think, okay, let's do that. Ammonia is this. First of all, knowing the right formula is very much important. Nitrogen's configuration, hydrogen's configuration, we should know that as well. Otherwise, how will you draw it? Nitrogen going to combine with 3 hydrogen. Again, very clearly, I wrote 3 hydrogen like this. You can simply make it in that way also. But why ma'am wrote in this way? Because somehow I know that structure of ammonia is quite a pyramidal type. Okay, like this. Are you getting it? So yeah, that's why. Otherwise, if you can write it that way also. So by knowing chemistry is knowing structure also. How much valence electron nitrogen is having? That's 5. 1, 2, 3, 4, 5. Why 3 on this side? Very clearly, just because I can make my bonding very much easily, and there must be a great and neat diagram as well. Okay, let's see. Hydrogen share one electron with hydrogen hydrogen will share one more electron of nitrogen because there will be a bonding between them. Hydrogen and nitrogen share two electron, two electron. On the same way, nitrogen is like, I am having 5 electron, I need to share 3 electron, and I'll share these 3 electron with 3 different hydrogen because hydrogen also shared my 1, 1, 1. So I will also share its 1, 1, 1. Okay? Sharing 2 electrons, single bond, single bond, single bond. So the total structure that I observed, there are 3 single bond that I got, and this is a pair of electron that we didn't use, and that is called as a lone pair of electron. A pair of electron, that's a loner that we are not using in bonding. Okay? So that's a lone pair of electron. I hope the structure is pretty much clear. Ma'am drew it in front of you. This is like a actual pictorial one, and I know drawing is not that good, but it's adjustable. Okay, let's see how water structure is drawn. That's H2O. Now you can draw it totally like this, but you know, exact structure of water is this: a V shape, inverted V shape. Oxygen is combining with 2 hydrogen like this shape, V shape. Oxygen's configuration 2, 6, hydrogen 1. Very much important to know that. All right. So first of all, write hydrogen's electron, valence electron. Write 2 electron of oxygen on this straight line itself, so that diagram will look clean. 2 electron I've drawn. 4 is left. Done, done. Let's do the bonding itself, and yeah. Hydrogen sharing a 1 electron. Why different colors? So that you can totally see that. Both hydrogen stable following its duplet. 6 electron, 7 and 8. Oxygen is also stable by mutually sharing 2 electron from 1, 1 hydrogen. Single bond, single bond. These 2 electron pair we didn't use. So structure will become single bond, in total 2 single bond, and this 1 and 2 pair of electron, didn't use lone pair of electrons on oxygen. All right. Yes, now it makes sense. Now you know different kind of bonding, covalent bonding, single, double and triple. So now you are totally ready to draw carbon's compound also, and the very simple carbon compound in front of you is methane. Methane's formula is CH4. A carbon is attaching to 4 hydrogen, and you know carbon is having a configuration 2, 4, hydrogen 1. Very much simple. Again, 2 way to write it. One is like easy way, write it like the square, but somehow I know the structure. If you don't know, it's totally okay. Not like a rocket science, not like it's necessary to do the same. Every hydrogen is having 1, 1 electron. I'll draw the actual structure also. This one like a tetrahedral. Okay, like a tetrahedral. Looks like this. Okay, yeah. Hydrogen's electron I wrote. Let's write carbon's electron. 4 electron. 1, 2, 3, 4. Let's show bonding as well. Okay, and let me take a different color. Hydrogen will share 1, 1 electron with every carbon. All right, done. And stable, carbon equal sharing. So carbon is like 4 of mine. 4 in total electrons I will share from 4 hydrogen. Equal amount of sharing. Mutual sharing. Carbon stable, check. Hydrogen stable, double check. And the amount of bonding that I see is total hydrogen carbon share 2 electrons, single bond. Hydrogen carbon share 2 electrons, single bond and single bond. That we got is this CH4. Okay, or you can draw like this also, CH4, because this is like a better structure, right structure, but no one will get even a single mark if you'll draw in that way as well. Yeah, so carbon's simplest structure is carbon making single bond with hydrogen and giving you CH4 in front of you. You want to see it clearly, I'll erase that area. Yeah, you see that. That's what I drew. Yeah. So that's pretty much clear. So compounds formed by sharing of electrons, we did discuss hydrogen, chlorine, methane, H2O. Sharing is caring, that's giving us covalent bond. And transfer of electron is not happening, just sharing and overlapping each other's electron and giving covalent bond. This is covalent. Do remember, covalent bonding is also kind of very strong, but in a molecule, intramolecule. But when I talk about intermolecule force of attraction, that's a bit less. You didn't get it? I'll help you. Suppose I'm talking about water only. That's water, HOH. This bond, that's intermolecular force of attraction. Intramolecular force of attraction. Intramolecular, intra inside the molecule. Force of attraction, this is also kind of force of attraction. Your covalent bonding is what? Bonding is nothing but force of attraction between two atoms. So this kind of a force of attraction due to overlapping of electron is kind of very strong. So intramolecular force of attraction, very strong within the molecule. But when I talk about intermolecule, means with a different molecule. Water with different water molecule. Suppose this is different water molecule I've drawn. There are so many water molecule. This is different water molecule, and all together there's a big glass of suppose H2O filled. There are so many water molecule. So this force of attraction between different water molecule, this force of attraction is a bit weak. And that's one of the reason that covalent compound is having lesser melting and boiling point and generally in liquid and gaseous form due to this weak intermolecular force of attraction. Look at that, intermolecular forces are small. Okay, and intramolecular covalent bonding, that's covalent bonding inside the molecule due to overlapping is very much strong. So you got the point that they have low melting and boiling point due to this weak kind of a force of attraction that it is having, and they are just what sharing of electrons, so no charges developing on them, and that just because of the same they are poor conductor of electricity as well, because for conduction of electricity there must be free ions, and in covalent compounds there are no ions. Yeah, that statement is partially correct, by the way. In higher class, in 11th class, you will talk about different kind of a covalent bonding also, where there is a case that in some of the covalent compound there must be a little charge separation, and you'll call them polar covalent compound. Polar means generating polarity, generating charge difference. Water is one of the example. Not right now, in higher classes. For right now, you can say my covalent compounds are nothing but poor conductor of electricity, as there are no free ions. So I have different cases you're able to do that. So there is some homework for you, because not doing homework is not a great idea. I will really appreciate if you fill the comment section with your responses, homework, as well as how do you like the session. Do differences in ionic and covalent compound, very much important. One I am giving to you as well, that you can mail it to me as well. Write down the structure of CO2 the way we drew the structure of CH4. Try drawing the structure of CO2, carbon dioxide, and I'll show you my email ID as well. There is one more question in front of you, so take a screenshot to let me know that homework is completed, ma'am. We did do that. So bonding in carbon compounds, covalent bonding is pretty much clear. In next session, we'll talk about why carbon is so versatile, and recent studies like carbon's compound is like around 10 million. Why? We'll talk about the same. Okay, students, do not forget to select your course by going to the Vedantu 9th pinned message, a link. Select your grade, select your target, choose your subscription wisely from 3 modules, 1 month, 3 months and 6 months, and you can save 20 to 43% discount can have a session in as low as 8 to 10 rupees. Take it as an opportunity, do not miss it. 2159 for a month to come and see how all the session happens with wonderful animation, GIF, interactive sessions. For 3 months cost reduced to 1866, for 6 months cost reduced to 1533 because of the special code that you have applied. After applying coupon code, this is the price, AGEPRO. AG ma'am's code is AGEPRO. So this is my email ID as well, where you can submit your homework, anubha.kaur@vedanta.com. Hope you already liked it. If you haven't done it yet, do it. Subscribe to the channel if you haven't done it yet. Very much important. Support it equally. Make it a big hit. Ma'am will see you next time. Until then, take care of yourself. Keep revising. Stay happy. Bye.